All right, now the moment of truth. Now you see the topics.
What's a bad translation?
Perfect. All right. Yeah, so this is what we'll cover, and we can leave everything else for the Q&A. Thanks for interrupting me. So what's a bad translation? It's actually not very simple. This is a real example. So of course, we would normally say that the top one is more correct in that actual translation memory, which was done by a human. Actually, French, Français should be translated to English. But this is very hard for you to know without more context. Here's an example you often see. So something is explained on the one side, maybe because it's an Anglicism. We don't really want to have virtual private network parentheses virtual private network in English. So I would call this a good translation by modern MT. And here you have one from someone from our own community, from Remy Blecher. And he was pointing out that if you say zu dritt in German, it says in a threesome in English, and he find that funny, which shows where his mind is. I looked in the dictionary, it is correct. On the other hand, if people find it wrong, it's wrong, right? And he is the CTO at Supertext, so he totally knows what he's talking about. Therefore, it's wrong, even though it's right. This is another real example. Georgia coronavirus cases reached 385. Guess which one it was? Well, it was Georgia, the country. Of course, you'd have to know the date, maybe even as a human, to guess that. Very different energy between these two videos. I'll let you play it at home. So if we kind of look at our average data set, there is no average, right? But we look at them. There's stuff that's definitely right according to some bar. There is stuff that's definitely wrong according to any bar. And there is a lot in that depends on context. And I don't know what the exact number is, but it's something like the majority, if we're really sort of exacting. So they kind of fall into these errors. So not professional human quality. I mean, most machine translation is not really beautiful at this point, and never will be, because I don't think that's what we want from machine translation. Has an error, is so bad it's not understandable, and then catastrophic. So catastrophic is even worse than not understandable. Catastrophic means it's the F word, or you don't even know what topic it is, or it's not even left in the source language. And that's something that maybe, we don't care to split those out if we're a client of machine translation necessarily, but the machine translation researchers really care about that, because it's the thing they tend to hear about their boss from. Or, you know, you have a story like Facebook, Facebook translates something wrong and the guy got arrested, real story. So can we catch these? Yeah, so our company, obviously, we believe that at least some of them we can catch, right? The ones that are always wrong, I think we should catch. The stuff that's dependent on context, now it gets fuzzier. And then it would be really nice if the stuff that's always correct, if we could say, hey, this is correct. So I'll go back to the Zurich machine translation meetup last summer. We were having beer, and Samuel sort of was joking. Well, he was, but it's true. So it's the holy grail if it works. So the question is, does it work? And it's really a numbers game, right? Everyone's very familiar with these numbers, with these concepts right now because of the coronavirus. So you have a threshold, you take a test, you have true positives, false negatives, and precision and recall. We don't talk about accuracy a lot because these are very imbalanced sets. So you can get 90% accuracy without being very good necessarily. So, right, you have your coronavirus test, the outcome, good outcomes here, low predicted risk. So it does correlate. You see a clear correlation, but it's not perfect. No different. Quality, right? So quality is getting worse as predicted risk is going up. So depending on the use case, but you're usually setting a threshold and saying, look, everything with risk greater than this, we're going to look at. Is it perfect? No. I mean, realistically, right? So these are high quality translations, which were flagged as risky. Not as very high risk in this case, but still risky. This is totally fake image, by the way, from Google Images. Okay, nothing. I flipped it a few times to get it right and everything. It has nothing to do with anybody's data set. And on the other hand, you do have something with low quality and low predicted risk. So this is what we call a false negative. So we let this one go by. This one hit users, bad translation, right? But you know, the other thing to keep in mind here is the distribution, the total distribution. Most machine translations are good. So even, even at the accuracy we have today, you are able to, look, all of this stuff got approved and nothing really bad happened. So how to use risk prediction, right? Where can you put it into action? Well, estimating human post-editing effort in the translation industry, they get a job, they want to know how much will this take with this engine, how much should I charge for it, or how much should I pay for it? The thing they're most interested in is auto-approving raw machine translation for as many segments as possible without hurting quality. That's what we mean by safely. So set the threshold so that the translation quality stays the same as today, keeping in mind that it's not perfect today. It's even with humans, they don't catch everything. And then checking the final human translations, which are typically coming back from either a different person or an external company even. So machine translation wants to filter the training data. So this could be a research org, this could be somebody who is just training custom machine translation on Google Translate or AutoML, or Microsoft. Evaluating and comparing systems. People love this. It's like hot or not or something, right? They just want to know, like, does Google or Microsoft do better on my data? But of course, Microsoft and Google also care a lot about, is Microsoft or Google doing better on different data sets? So in tech platforms, right? Tech platforms are different than, you kind of have UI strings, which go through the traditional translation workflow that we looked at before, but then you have content, right? So TripAdvisor can't really manually translate all reviews into all languages, for example. So the scale is just too high. So it's just about triaging, damage control. Again, coronavirus concept. So translation apps, I mean, translation.google.com is a different thing than the API. You have actually a lot of cool apps out there, sort of special purpose ones for subtitles, for voice, conversational. And conversational, it's really important to sort of stop there. Let's say something was translated wrong or the speech recognition was wrong, stop, come back to the user, say, can you rephrase that so to avoid a bad outcome? Language learning also, I mean, I don't like Duolingo. I know a lot of languages. I'll never use Duolingo because it's not real fresh content, and you can only be motivated by real fresh content. There are apps out there doing that, and because it's fresh content, they have to use machine translation. However, machine translation doesn't work, so that's another use case we love to support. Then finally, the thing that's most interesting for this crowd is, I know most of you are not working in machine translation. You are in a company and you have a bunch of NLP models. Could be for catching spam or finding proteins in a research paper, finding reactions or something like that, search indices, and you have it only for English or maybe only for the few languages, and now you want to add 10 languages or 100 languages. So how can you make your system multilingual? And we'll dive into that deeper later on. So first one use case we'll look at is the machine translation use case, which is just getting good parallel data, which is still maybe the biggest determiner of machine translation quality today, given that all the algorithms are open source. So machine translation data comes from three things: human translation memory, so from the traditional localization workflow, crawling the web, and back translating monolingual corpora. I mean, Microsoft or Google are back translating maybe at a ratio of 100 to 1. Roughly, right? So because it's just so much easier to find monolingual data, and you back translate, and then always filtering, right? So all of these have mistakes or things you don't want to train on. Noisifying a little bit to be robust to noise, and then balancing, so upsampling the good stuff so that your synthetic stuff is only 50% max, let's say. So curiously good output, and I think this has applications not just for machine translation. This is for any sec-to-sec problem, maybe any NLP problem, that something can be good enough output in context, or even perfect human output in context. That doesn't always mean that it's good training data. So what do I mean here? So if we look here like at this, so maybe this was a nice idiomatic translation, typical one you see. They translate the president to the guy's name because in their context, a president could be anybody. But you don't want to train on that because bad things happen, right? Phone number is different, but you don't want that in your training data. Unit conversions, at some level, both of these are wrong, or maybe in some story, this could be right, but very idiomatic. You paid a lot for this boutique translation. You don't want it in your training data. So, and then of course, just general structural differences are nasty. You get weird surprises out of these. So this is all kind of stuff that you probably want to drop if you're training machine translation. So general theme here is lack of one-to-oneness. So is translation symmetric? Does translating a sentence in one direction automatically mean that that translation back to the original is a good translation? It's actually not that simple. So we have, of course, a lot of Denglisch in the Werbung. Welcome to California. You can see this on all these magazines. Every time I come back to Europe, there's more of it. And you might have something like Grüezi miteinander. Now you translate that to English. Again, maybe it should be hello or something, or hello y'all. And Tschüsschen, this of course is you know, not language that I condone, but it happens in real data, in dirty data. And something like these 42 neue Corona-Fälle in Georgia, der US-Bundesstaat. So back translation, again, this very popular technique. You get welcome to California in English, right? Still welcome to California. You get hello, you get bye, you get Georgia, and here you have like Schreibfehler, would become writing errors. Now we flip it and we're gonna train English to German. Well, now we got all these dirty target side translations. And we can say, okay, we like Grüezi miteinander, but we also got stuck with Tschüsschen, so it's a net loss. How much to filter out? This is probably best described in the laser paper from Holger Schwenk, Michael Archete, right? So you have basically your risk threshold, or in their case, their vector similarity, and you drop, and it's peaking. Translation is getting better. We'll use blue. I don't condone that either, but I'm just putting it as an example. And then if you drop too much, of course, your translation quality will again get worse. So some diversity and noise is good. You're throwing away too much good stuff, and there's not enough bad stuff. The good news here is that, I mean, the actual distribution by risk or by quality is typically like this. And again, these are all fake numbers, fake graphs, but it's like this. So you can drop everything above 10% risk or whatever and still keep 90% of your data. I'm going to show you an example here. So these are all available in the slides, by the way. These are all public. Let me just go here to this, right? So here's a typical example. This is being used at WMT, for example, wiki titles. So the title of Wikipedia article in one language with a title in the other to train named entities. And look at this distribution, right? I mean, we can just throw away, we have like 25K lines. If we drop everything below 50%, okay, 19 something. Why not drop everything below 15%? We still keep 16K. We barely lost anything, right? Okay, we dropped this bad one, right? And this is a very nice trade-off for this kind of use case. So, and then this is now human translations put together by Taos, right, an industry group. So a bunch of translation companies contributed for the common good, Corona and medical related translations, human translations, about 1 million, 500,000 for each language, English, Spanish, and so on, German. And here you see, of course, this quality is much better, right? And it's amazing. I mean, so out of, you know, more than 500,000 translations, only like 2,000 are bad. And I asked them, so how many did you cut in the end? I thought they would cut 10%. They said, we threw away everything over 5% because it was still more than 90% of their data, right? So why take the risk? They have so much. So the distribution is very skewed. And we can talk more about that later, but we are going to, those are both public, and we're going to be releasing free risk predictions for all of the WMT data sets, for all the language pairs coming up. Want to get the quality right for the very long tail languages. And I think this is going to be a real game changer, because if you look at the last year, Microsoft had this winning system, and it was with like the same algorithm as the year before, but just with better data cleaning. And so I cannot stress enough how important it is to clean your data. And I want to level the playing field, and basically everybody can start off from that same base and go from there. Now they can pick the threshold since everything is free, downloadable, etc. But I think it will really be a game changer. Of course, we don't participate in WMT, but we do try to support as much as we can. So the other use case we mentioned was how to evaluate and compare MT. We're in an eval crisis. I mean, blue was never a great metric, and it is still the standard for sector-sec tasks, not even just translation, and blue is broken. So what I mean by blue here, I don't care. Any of them, Sacre Blue or Meteor, Levenstein distance, it's all basically comparing the output of the machine translation model to a reference translation, which you have basically by splitting your training data into training and test. It does not correlate with human eval on a high quality system. So if you look, right, okay, yes, it correlates, but all we care about is the best systems, right, the winners. And if you look at the winners, it's anti-correlated even. So this is obviously not working, and the people with the best systems can't use this anymore. There's another question, of course, which is, does human eval correlate with human eval? This is some of the stuff we did. We also provided labeled data for WMT. Very tough stuff. It's very hard for me to think of a client use case where they would want one of these to be good and one of these to be labeled bad. They're either both risky because translating sayings and proverbs is risky, or they're both fine because nothing that bad happened. This is something we see all the time. Blue doesn't care about it. So these are, source code. We, as programmers, we know this matters. And you ask the linguists, they don't care about it because they're not programmers. And then you ask the WMT organizers, they don't care about it. But every single client has this problem, right? So these two things are sort of misaligned. So inter-annotator agreement looks pretty much like the Ukrainian parliament. And people much smarter than myself have said this, including people from our community. This is probably the hottest paper on this topic right now, right out of Zurich. Samuel Leubli, Rico Sendrich, also part of this community and supporter. So what will replace blue? People like, again, much smarter than myself, Alon Lavi, for example, Maxim Khalilov, are saying quality estimation as evaluation. So this means aggregating line level scores. You just take all the line level scores and you average them for that corpus. So the idea is, right, I mean, blue, it doesn't work the other way around. You can't take a corpus level score and say, oh, this segment is predicted well, but you can take segment level scores and calculate great corpus level scores with lots of insights. So it's cool because it's automated even for new content. I mean, we call blue an automated metric, but you still need human reference translations. And a lot of times we need to see how machine translation is doing on new content, which we haven't human translated yet, maybe into a new language. It correlates with human evaluation. And in fact, it correlates better with human evaluation as quality improves. At the very low end, it depends, right? Because we don't, let's say, care about all the adversarially bad translations. It's customizable, right? So we're not just focusing on post-editing distance or something like that. Some people only care about the catastrophic stuff. Some people care a lot about that the quotation marks should be the Swiss German way and not the German way. We've had weird requests, transliteration, that the translation of a UI string should take into account the gender of the user. Quality estimation is, again, just all you get. You don't get any reference translation. You, in a black box setup, you don't get any internal variables from the translation model. All you get basically is the input string and the output string, and now you need to give back a score. That's all we work with. Nothing else factors into the decision, even if it should, right? Maybe we should use context, or go to Google Images and see what it shows, but we don't. Right now it's just like this. So we need to be just directionally correct. So have to basically get the ranking right. This system is better than the other system, and it helps humans. It's not to replace humans. It's to sort of guide humans to then say, okay, I need to go look at that, right? Out of a million line eval. So we've made it pretty easy, just a drag and drop process. Human evals are obviously very, very expensive. So you can just drop in your, pick your languages, pick an engine if you want to do that, or upload your parallel file with your own translations, let it run, and maybe then pick a different engine. So instead of Google, DeepL, and get an email when it's done with a histogram like we showed you, and fully able to download the results, sort by risk, etc. So now to the use case, which I think interests most of you the most, which is how to make your NLP multilingual. And again, what we mean here is something could be classification. That's sort of an easy one. But could be something like named entity recognition, where somebody, professional medical folks, have annotated the proteins, the reactions, the agents, and all of that for, let's say, 10,000 lines, which isn't that much anyway. It's just so expensive. And now you want this for 10 languages or 100 languages, especially in these times where medical information is very important. There are sort of 4 basic approaches to these. Get new human labels, so you just pay humans for that. That's obviously very slow and expensive. Translate to English at inference or query time. I would say this is the most popular option. Very good NLP companies doing this. I think this is very bad. Firstly, it's slow and bad engineering to have more complexity at query time. Secondly, there's no recourse. So let's say you have ModelFront. ModelFront is God level, and we say, oh, this was a bad translation. What do you do? There's no, at that point, it's too late to do anything about it, because you're not going to have a human intervene, right? So I don't recommend that, but way too many people are doing that. You can use laser or BERT or some way to sort of generalize zero shot. This is risky. I can point you to concrete things going way, way wrong with smaller languages. And it's also, again, a little bit complex at deployment time. So, and even at training time. And so it's definitely also common, and I would say growing. It just comes with some trade-offs. So the easiest way I would say is to machine translate before you train. So machine translate your training data with the labels, keeping the annotations, and you take advantage of the fact that all of these machine translation APIs support HTML tags. So you need to, whatever format you have it in, get it into XML-ish tags, and then you can just machine translate it. And then, of course, again, like with machine translation itself, a filter, so drop bad stuff, noisify, so kind of make it more diverse and robust to noise, and then rebalance, upsample your synthetic stuff to get, again, a nice ratio. You know, I'm not saying this is mutually exclusive, right? You might want to do A and D. So get some human ones, especially if you notice you're dropping a certain type more than others with the filtering, and then kind of rebalance. So the risks here for your NLP model is firstly that the translation messes up the meaning or the structure, that it messes up the tags, and then of course that the diversity and balance is not preserved, right? So if all the machine translation errors are on a certain kind of input, that means that your translations of that data set are going to be sort of skewed because they won't have any of that kind of input. So that's a risk to watch out for. So I did it very quickly on this data set that I have. It's a very simple data set. This is probably the kind of thing where you could use BERT or laser. So Amazon reviews for sentiment analysis. Basically, they scraped reviews. 2 stars is bad, 1 or 2 stars is bad, 3 or 4 stars is good, and 3 stars they threw away. 4 million. Through some here on ModelFront, I used Modern MT, which is my favorite engine these days, English to Russian. And okay, that ran and finished. I've put that up. Let's have a quick look at it. Right, so here you see the distribution. It's actually not as good as I would have expected. And you know, Modern MT, very good engine. And I'm looking, okay. what's going on here? I'm like, oh no, ModelFront has a bug, which is like, oh my God, we have a presentation and we have a bug. It's supposed to be English to Russian and it's just Spanish. No, actually there's in the English data, there's Spanish. You don't have US English data without some Spanish in it. At scale, there's always Spanish in the English data. And modern MT just translates the Spanish to Spanish. Okay, actually for this use case, that's not that bad. That's not a problem, right? Because, okay, more languages in the model, Spanish, as long as we kept the label, which we did, that's great. Okay, scroll down some more and we see, oh, now it's English and it just stayed as English. Okay, what's going on here? I downloaded these a few minutes ago and looked in here and I see what's going on. And actually, so we have a bunch of these at the top that did not get translated. And what happened? So modern MT is taking the fast text label as a sign that this is a not really language. And that's maybe a feature, not a bug. So if we go to modern MT, we just go to modern MT here. Like the folks at Text Shuttle, I'm just always playing with these engines all day long. English, English, English. And we go to, let's say, Russian. Just want to make sure it's not just the API or a bug. Nope, this is really happening. And
Adam?
Go ahead.
So we cannot see the other screen.
Ah, okay.
Kind of imagining how you click there.
Yes, let me try and share my screen here.
Until you do that, I would like to encourage the audience to look at the Q&As, upvote them if you have the same question or add a new question. And we will take the time to discuss your questions after the talk.
Do you see the Modern MT website now?
Yes.
All right. So I'm looking at this at what went wrong here, and now I'm going to delete the label, and okay, that fixes everything. So modern MT has something, feature or bug, I don't know, but when it has a fast text label in front of it, it's not translating. So what did we learn here? Okay, we need to go back and take the translation column only, drop those labels. So basically translate without the labels, then add the labels back in. It will be the same number of lines. Everything will work beautifully. Okay, yeah, so I did that in Firefox. I'm not really a Chrome user. Sorry about that. You see now again, ModelFront, correct? And,
yes.
All right, and I'll go back to presentation. All right, so, and I guess the thing to keep in mind here too, is that if we hadn't sorted these, if we didn't use ModelFront, we would have never noticed.
My bad.
Go ahead. Okay, now
ModelFront is not there. Modern MT is there.
Okay, let me stop sharing and let me share.
Thanks.
Okay, numbers. Right, I'm looking at this whole spreadsheet as it in the original order, and you would never notice that there was a problem here because it doesn't happen that often. And it's only with the sorting by risk that you catch this issue and know, okay, I need to, separate out these labels. All right, so the very last slide here basically is, so when you do this, you've translated all of your data into all of these languages. A lot of people are saying, okay, I have a English NER model and a Russian NER model and this. And as we saw, there will always be mixed language. You really can't guarantee. Monolingualism, like in Switzerland, like in Armenia, in the US too to some degree, is a fact of life. It's not some weird edge case. Actually, every country in the world right now has English in their content mixed in, right? Whether it's a URL or whatever. So it's always there. So I highly encourage you to just do one big model. It's also much easier for engineering and deployment and so on. Just much safer for most of the tasks. There may be some exceptions, but it should be the default. And right now the default is the other way, and that's not a good idea. So With that, yes, merci vielmals. I am ready for questions, and let's hear what you have to say.